Hello everyone. Today I've decided to study this blog post on Google Research portal where they are talking about how to teach AI to read a map. Let me clarify this very clearly. I have zero knowledge about this domain. I have studied basics of machine learning, but then I am not a researcher or a geek in this. My whole objective of making this video is to learn it myself, and if along the way, if it helps somebody out there, it is good. Otherwise, this video making process forces me to study this in depth and explain the concepts live on the video. This is for my own self-interest that I'm doing it. No way I'm claiming that I know this topic well and I'm going to teach you. No, I don't have that acumen as of now to teach you. Yeah, so it's more of a self-study video. Let's get started. So this was released on 17th of February 2026, just a few days back, where they're talking about teaching AI to read a map. Now this video, this diagram shows a image where they are showing a route, arrow based direction from a source to a destination, and asking AI, I think, a prompt like show me the path from point A to point B over the provided map. And they use multimodal large language model. Let us study this in detail. We propose a system for synthetic data generation to train AI systems to visually follow any route on any map, finally teaching language models to navigate our world. Okay. Look at a map of a shopping mall or a theme park. Within seconds, your brain processes the visual information, identifies the location, and traces the path to your destination. You instinctively understand what lines are walls and which are walkways. This fundamental skill, fine-grained spatial reasoning, is second nature. Okay, so this way of understanding things by looking at visuals is how like our brain basically just looks at a map or an image and then is able to find like if you see Google Map, you will be able to see where your brain will be able to decipher that map and say, okay, this is the source, this is the destination, this is the route that the map is showing, and I will be able to navigate as per this. Now, how do we replicate the same brain's functionality into a AI system? So that is what they're trying to do. For all their incredible advancements, multimodal LLMs often struggle with this particular task. While multimodal LLMs can identify a picture of a zoo and list the animals you might find there, they may have difficult time tracing a valid path from entrance to the reptile house. Okay, so right now models can, like if you share an image, it will be able to tell what is there. If you share an image of a zoo, it will be able to list down all the animals out there, but they have a difficult time to trace a path from the entrance to a particular place inside that zoo. Basically, navigating a map is what they are trying to make AI do. They might draw a line straight through an enclosure or a gift shop, failing to respect the basic constraints of the environment. This reveals a critical gap. Today's models are excellent at recognizing what's in an image, but they falter when they need to understand the geometric and topological relationship between the objects. Okay. So far, so good. I was able to understand this much. Very basic understanding. To address this challenge in map trace scalable data generation for routing tracing on maps, let me see what it is. This is paper on map trace scalable data generation for route tracing on map. Okay, I won't get into detail of this. To address this challenge, this map trace paper, we introduced a new task, a data set and synthetic data generation. So synthetic data generation, so let me I read this yesterday, so I'll explain this. So AI needs data to train upon, some kind of data set. Now it could be historical data, but then assuming today's AI has consumed all the historical data that is out there on internet and knows what to do based on that data or the patterns it found on that there. Now suppose for new training data, there needs to be a way to synthetically generate training data. It could be, say, if you're training an agent to review PRs, code review, it needs to generate sample code and then tell you which is correct, which is not correct, and then generate a lot of synthetic good data and then train its LLM with that data. That way we can not depend on historic data and just do a lot of things with synthetic data generation. Now the same thing is being done here, where they introduced a paper which talk about map trace scalable data generation for route tracing on maps. So on maps they want to generate data, synthetic data at a very large scale for route tracing, for tracing route on a map. Now they introduced a new task, a data set and a synthetic data generation pipeline designed to teach multi-model LLM the fundamental skill of tracing path on map. Okay, to be able to trace path on a map, they created a synthetic data generation pipeline, sampled a data set and a new task. Let us read about it in detail. Our work shows that this complex spatial ability like related to geospatial, so this shows this complex spatial ability, largely absent from pre-trained models, can be explicitly taught through targeted, synthetically generated data. Okay, we also open source 2 million question and answer pairs. Let us see what it is. This is on Hugging Face, and this was 2 million path designed to train models on route tracing path. Okay, they generated 2 million question and answer pairs generated with the proposed pipeline utilizing Gemini 2.5 Pro model and Image Gen 4 models to encourage the research community to further explore this area. Okay, let me read about this diagram. Given a start and end location on a map, the model outputs a valid path that respects map constraints. We observed that the generated images tend to render text incorrectly. However, we mostly focus on path qualities in this work. We believe that with improvement in image generation models, these artifacts can be easily suppressed in future work. Okay, this is Gemini 2.5 model, and this is Image Gen, which is basically text to image generation model. This was used to create the route tracing on map. This is Q&A. Okay, the challenge, the lack of grounding in the physical world. Why is tracing a path on a map so hard for AI models? It boils down to data. Multi-model large language models learn from vast data set of images and text. They learn to associate the word path with images of sidewalks and trails. However, they rarely see data that explicitly teaches them the rules of navigation. However, Okay, so navigation means you decide which way to turn, left and right, based on the view of a map. Like right now, if you see a Google map, you will be able to say, okay, this is the road, this is a house, and you can't take your car on top of a house. You will have to follow the trajectory of the road. Now this knowledge humans have, but how do we translate this knowledge in a AI model. So that's what they're talking about. They say that AI models associate word path with images of sidewalk and trails. However, they rarely see data that explicitly teaches them the rules of navigation. You know, that paths have connectivity, that you can't walk through walls, and that a route is an ordered sequence of connected points. Yeah, that's the knowledge of navigation. The most direct way to teach this would be to collect a massive data set of maps with millions of paths traced by hand. The most direct way to teach this would be to collect a massive data set of maps with millions of paths traced by hand. By annotating a single path with pixel level accuracy is a painstaking process, and scaling it to the level required to train a large model is practically impossible. Furthermore, many of the best examples of complex maps, like those of malls, museums, and theme parks, are proprietary and cannot be collected for research. So basically what they are saying is, in order to train a model, we need large collection of massive data set of maps. We need to collect a massive data set of maps with millions of paths traced by hands. If you see an image, if you see an image of a road trajectory and you say point A to point B is the direction I want AI to learn, we need to tell AI on that image what is the route from point A to point B by hand tracing it. So it understands, okay, and if we give this like really large data set of maps to AI, then AI will be able to get that, what they're talking about, the rules of navigation, to be able to navigate through that. It will be able to understand the rules of navigation, like it cannot walk through the wall, that the route is an ordered sequence of connected points. It has to arrange that sequence of arrows in the correct order in order to come up with the correct path that the user is looking for. Now, the problem they are saying is the path should be traced by hand on each image. Now, but this annotating of a single path with pixel level accuracy is painstaking process, and scaling it to the level required to train a large model is practically impossible. It is impossible to trace the path on millions or billions of images by hand. So the challenge is, how do we generate such data set? Furthermore, many of the best examples of complex maps, like those of malls, museums, and theme parks, are proprietary and cannot be easily collected for research. Yeah, so all these navigation maps of malls, museums, and theme parks are like proprietary and cannot be collected for research. This data bottleneck has held back progress. Without sufficient training examples, models lack the spatial grammar to interpret a map correctly. They see a group of pixels, not a structured navigable space. Okay, we understood what the challenge they are trying to solve or address. Okay, let us see what solution they propose. Okay. Okay, nice. Let us do it in part 2 of this. Thank you.